Okay, the diagram shows a design for a circuit found inside computers. The purpose of the circuit is to turn on a fan when it gets too hot. The fan is functioning properly when the current through it is at least 1.2 amps. The graph shows how the resistance of the thermistor varies with temperature. After an hour of use, the temperature of the computer has increased from 20 degrees to 35 degrees. Assume the fan's resistance is constant, so this is 50 degrees and it stays 50 degrees over this temperature range, and the internal resistance of the cell is negligible. Determine if the circuit is suitable in this particular situation. Okay, so we're going to see how it changes as the temperature of the computer increases. So starting off at 20 degrees, and which gives us a resistance of 250 ohms for the thermistor, and then after it's been on for some time, it goes to 35, which is over here, and that has a reading of 140 ohms. So the resistance of this decreases as the temperature increases to 140 ohms, and we want the fan turns on when the current through it is at least 1.2 amps. So let's check what's going to happen. Because it's a series circuit, let's check what's happening at 20 degrees. So the total voltage is, I'm going to use Ohm's law to figure out the current, V over R. So at the start, when it's 230 volts, and the total resistance in the circuit is going to be 250 plus the 50 ohms, and that will give me a current of 0.767 amps, which isn't high enough to turn the fan on. Okay, so the fan isn't really working. Let's try what happens when the temperature is increased to 35 degrees and the resistance is now decreased to 140. So current is now, the voltage is still the same, 230 volts. Okay, the resistance is now 140 plus the 50. The resistance of the fan hasn't changed, and that gives me a current of 1.21 amps. So now that is above 1.2 amps, so the fan will turn on and it will work. So this circuit, we can conclude, is suitable. Okay, which of the two circuits below, A or B, is suitable in a device which is designed to keep the a box above a minimum temperature? Explain your choice. Okay, so we're going to look at what happens to both circuits when the temperature starts to decrease. Okay, so let's look at this one. As the temperature here starts to decrease, we know the resistance is going to increase because there's a negative temperature coefficient thermistor. So if the resistance of this thermistor increases, it's going to start to get a larger voltage, larger fraction of the voltage compared to the fixed resistor. So the voltage of the fixed resistor will decrease. And because that fixed resistor is in parallel with the heater, the voltage across the heater will decrease as well. So as the temperature decreases, the voltage across the heater decreases. So that's not what we want, because we'd want the heater to receive a larger voltage and turn on. So this circuit is not suitable. Let me just show you that the circuit B is suitable. So as temperature goes down, the resistance again goes up. So the voltage, you'll get a larger fraction of the voltage compared to the other one. And you can see straight away, if the voltage of that goes up, the voltage across the heater must also go up as well, because they're parallel and they should have the same voltage. And the voltage of the fixed resistor does decrease, but that doesn't matter too much in this case. So circuit B is suitable because as the temperature decreases, the resistance of the thermistor increases, and the thermistor and heater combination gets a larger fraction of the total voltage. Okay, part B is asking us, how can we repurpose circuit A? So what could we connect instead of heater that makes this a circuit more useful? So I think maybe a fan. Okay, let's see why. Okay, so if the temperature goes up here, the resistance will go down, and the voltage across the thermistor would go down as well. That means the voltage across the fixed resistor will go up, and the voltage across the fan will also go on, increase, and that means that the fan will turn on. So this circuit would be better if it was a fan connected on that case, because when it gets too hot, the fan will turn on. Okay, in the circuit shown, explain what happens to PD across the pump when the temperature increases. So if the temperature increases, the thermistor's resistance decreases. So what effect will this have? So because this is in parallel with this 95 ohm pump, the resistance of this whole combination, the total resistance of that combination, will decrease. So if that combination has a lower resistance, that means that combination will receive a low voltage both here and here. So the voltage across the pump will decrease, and of course the voltage across the variable resistor here, R, will increase. Okay, when the temperature of the environment is 32 degrees, the resistance of the thermistor is 140. So we can put this 140 ohms. Okay, the designer wants the PD across the pump to be around 180 volts at this temperature. So that's 180 volts here. Okay, well that means that this will also be 180 volts at that point. Suggest a suitable value for R. Okay, so I mean, I'm looking at this, it's just a circuit problem here. We know the resistance and the voltage, and the resistance and the voltage for these two here. So we can figure out the current through them. I could do this by doing a total resistance of this combination and dividing by total voltage of that combination, but I'm just going to work out the current through each branch. If I apply V Ohm's law to each branch there, I find that the current to the top branch is 1.286 amps. The current to the bottom branch is 1.895 amps. And of course at this junction here they join together, okay, and then they flow through this here. So we got the current through the source. If you add those two currents up, we get 3.180 amps. And we know the voltage across as well, because we know that has to add up to 230. So 230 minus the 180 gives us a voltage of 50 volts here. So now applying Ohm's law to this one, we can figure out the resistance. So resistance of this will equal V over I, and the V is 50, I is the combined current there, the total current in the circuit, and that gives me a total of 15.7 ohms. So I should set the variable resistance to 15.7 ohms if I want these desired outcomes.